Learn fiber optics with SENKO. A data center is a dedicated space within a building or a group of buildings used for storing data and sharing critical applications. Since the advent of the digital era, there were reported to be more than 7 million data centers that have been built worldwide. As the demand for more capacity and higher bandwidths continue in an upward trajectory, so does the technology needed to support it. Information to and within data centers must flow across many layers, which makes connectivity design a critical aspect. The most commonly deployed architecture in data centers is the two-layer, fully meshed leaf and spine architecture. The leaf layer is composed of switches that connect to end devices, such as servers, while the spine layer can be a layer 3 switch that serves as the backbone of the network. This will require more fiber cables to be run, since each leaf must be connected to every spine device. The common bit rates, reach, and medium interconnecting the various data center elements are as shown, and they will undoubtedly increase in the future. Let's have a look at the layout of a typical data center and the connections between the spine, leaf, and servers. The routers and spine switches are usually housed in the main distribution area, while the leaf switches are in the horizontal distribution area. The servers makes up the bulk of the equipment in the data center. To improve network efficiency, multi-lane transceivers such as QSFP-DD and OSFP are usually used in the leaf switch so that multiple servers can be connected to a single switch port. As the capacity requirement grows, more links between the leaf switch and servers will be needed. In this example, let's assume that we have 8 units of 1 RU leaf switches in a rack, and a total of 112 servers are linked to a single RU leaf switch. There will be a total of 896 optical links between the server racks and the leaf switch rack. It would be inefficient to take the point-to-point approach because the amount of optical jumpers will be overwhelming. This is when structured cabling will be needed to manage such a high fiber count. Before we keep going, we should understand what is structured cabling. In essence, structured cabling is a building or campus telecommunications cabling infrastructure which is intended to provide a standardized cabling approach using smaller elements as building blocks. Structured cabling will then deliver predictable performance, flexibility that maximizes system availability, redundancy, and scalability for future demand. With a structured cabling approach, the final result is a more organized and well-managed network when compared to the point-to-point method. With structured cabling, the number of cables are reduced between the leaf switches and servers from 896 jumpers to only 112 MPO trunk cables. Applying the conventional LC to MPO structured cabling approach, the links from the server to the patch panel are commonly LC to LC jumpers. LC to MPO cassette modules are deployed within the top of rack patch panels. Then the link from the patch panels to the switch rack will be MPO jumpers or trunk cables. Again, LC to MPO cassettes will be used at the switch rack, and LC to LC jumpers will be patched from the panels at the switch rack to the transceivers on the switches. Fundamentally, the use of structured cabling makes cabling more efficient. In the top of rack patch panel, the LC connectors of the cassette modules are presented in the front, while MPO connectors from trunk cables are connected at the back. In conventional setups, the LC to MPO cassette combines individual LC links from the servers into a single MPO trunk cable. Using another LC to MPO cassette, the MPO trunk cable is then broken out back into individual LC duplex connectors at the leaf switch. This requires the use of LC to MPO cassettes, which essentially houses an MPO to LC fan-out cord. The use of these modules adds to the overall deployment costs. The additional connectors in the module increase the insertion loss by an average of 0.5 dB when using high-quality interconnect solutions. Inherently, more components in the optical path add to the potential points of failure in the network. The introduction of the SN connector improves upon the conventional structured cabling. Comparing the conventional structured cabling method with the SN cabling method, the LC to MPO cassettes can be replaced by just a simple quad SN adapter while maintaining the advantages of high-density connectivity with the use of SN Uniboot connectors in the trunk cable. The SN Uniboot connector is designed with the ability to break out the fibers into individual duplex SN connectors. Expanding on the cabling changes with the use of SN connectors, it is possible to see the many benefits of this approach. Cassette modules are no longer required as the SN Uniboot 8-fiber trunk cable can be connected directly to the top of rack patch panels. This reduces the number of connections, which saves on overall deployment cost and improves optical performance. In addition, the smaller connector footprint can also increase connection density in the patch panel. The lower number of components in the rack improves airflow, which helps with cooling needs. Unlike MPO connectors, each of the SN connectors can be mated and demated separately without affecting the adjacent connections, which eases troubleshooting and deployment. With SN connectors, SN Uniboot trunk cables are managed in the back of the patch panel and connected to the adapters. In the front, individual SN connectors can be independently patched as and when needed. Let's now compare the insertion loss differences between the conventional versus SN cabling. Considering only the top of rack patch panels, and assuming the insertion loss are 0.25 dB per connection, the conventional method will have an estimated loss of 1 dB with each cassette having 2 connections. With the simplified SN method, the estimated total loss is only 0.5 dB. The versatility of the SN connector enables multiple different cabling approaches. The following are a couple of examples, but there are endless possibilities. In this example, instead of having the SN Uniboot connectors as the trunk cable connector, the SN MT8 connectors can be patched at the back of the patch panel. SN MT8 to SN Hydro breakout jumpers can be used to connect between the patch panel and the switch. If we utilize the SN MT16, we can have an SN MT16 to dual SN Uniboot as the trunk cable, and also as the breakout jumper from the switch patch panel to the transceivers at the switches. The use of SN MT16 connector will allow for a reduced number of trunk cables between the switch and server racks. As the connector footprint of the SNMT is the same as the SN connector, the SN-MT16 Uniboot connectors can be used as the trunk cable. SN-MT16 Uniboot to SN Uniboot breakout jumpers then can be used to break out the connection into individual duplex SN adapters in the patch panel on both ends. If the server uses the MPO-based transceivers, the SN-MT8 or 16 can be used. An MPO to SN-MT jumper can be the connection between the server and patch panel, while the trunking can be installed using the SN-MT Uniboot connector to improve density. In the switch rack, SN-MT jumpers can be deployed to connect between the patch panel and the switch. Due to the flexibility of the SN connector, MPO networks using cassette modules can be simplified to just a breakout jumper. Some of the key advantages of the SN approach are a lower link loss by reducing a connection with the absence of the LC to MPO breakout cassette, It will also be able to minimize points of failure due to a reduction of connection point. The SNMTs use 200-micron cladding rollable ribbon fibers that will significantly reduce the cable's outer diameter. This will not only reduce space and weight required in cable trunking, but also promote better airflow with less components. The absence of the cassette modules also simplifies logistics and inventory management. The SN connector simplifying networks. Because life is already complicated enough. Well, that's all the time we have. Hope you were able to learn something new about the advantages of the SN and SNMT connectors over conventional MPO connectors. Please like and subscribe to our YouTube channel for our latest updates, and we will see you in our next video.